Our research is on iterative simulation modeling framework of container housing system for architecture resilience in the coastal areas. So it sounds very uh, complicated, but it was actually not. We had a lot of fun during this research. So let me show you the outline of the study. First, we addressed the issue of climate challenges in coastal regions of Bangladesh. And as we are all architects, we try to achieve resiliency through architectural design. And we proposed a container housing system. And then through simulation modeling and energy optimization, we tried to establish a sustainable housing system. So coastal regions in Bangladesh, due to its geographic location, is among the most susceptible to natural disasters, facing frequent floods, cyclones, storm surges, and erosion of banks, which often leave the local areas devastated. As you can see in the picture, this is just after a cyclone. Locals have recently started using shipping containers as a housing unit. It is easily readily available due to the coastal areas, port areas are nearby, and these shipping containers are cheaper and more available. So we thought, why not use this as a construction unit and go further with our research. Uh, coastal So in this study, we describe a computer-aided energy simulation modeling workflow to compute daylight energy efficiency of a container housing system, which aims to be resilient and environmentally sustainable. So this is the region we chose, the port of Chittagong. This is our case area, and we got some weather data from the local publications, and we use these as parameters to find out how sustainable we can make this housing system. So this is a traditional housing system in Bangladesh. It is courtyard oriented. There are different types of courtyards: square shaped, rectangular, and then interlocking. Interlocking one usually goes when the family gets bigger and there are more houses than needed. So we incorporated all three of these in our parametric setting. And why container housing? According to some data, there are about 17 million of unused container shipping containers available in the world, and it is slowly becoming a popular construction unit. And shipping containers are capable in dropping construction period expenses, surplus wastage due to the stackable nature of the construction, and more importantly, researchers show that reprocessing containers for structures has an outcome of substantial reduction in the embodied energy as opposed to traditional edifices. So we thought that to battle cyclones, particularly cyclones, this could be a very useful construction unit. And as you can see from the picture, it is very easily the assembly is very easy, and cost and time goes really down. But what we asked ourselves is that how can the container be architecturally upcycled into a climate adaptive and energy efficient construction unit, and does it provide enough comfort for the people living in it? That is where we started our simulation processes. So this is the framework that we came up with through our research. Here you can see the first step was the case area selection, which I already mentioned was the Chittagong port area. And we took contextual cues for design and then put them as dependable variables. On the left, on step 2 on the left, you can see the dependable variables, and and on the right, the independent variables for energy optimization and daylight saving. And then combining all these, we formed cluster of buildings, and after that, the next step was performance simulation. This went through Ladybug tools and Honeybee and DaySim and Energy Plus. All of this combined and with weather data came into the next step, which is automated iteration. Automated iteration by TT Toolbox iterated design variables and aggregated UDI and UI results and visualization. And ultimately, we got exported iterated design input and output data and also visualizations. So now we will go for describing in the steps that which we followed, which we created this framework with. As you can see, in the red circled area, here is our site. Nearby is a stadium and the Katoli beach, which is right near the site, and the current living conditions you can see in the pictures. They are unhygienic and they are not very planned. They grow unplanned. So based on the courtyard data that we got from literature study, we generated 6 sort of modules that for the clusters. And hello? Can I be heard?
Yes, please carry on.
Yes,
Oh,
yeah.
all right, sorry. Okay. So we came up with 6 sort of modules through our literature study, and they were differentiated by stacking. The upper 3 modules that you see are single stacks, and the bottom 3 are multiple tiers. So single tier ones and multiple tier ones are same in square feet. So therefore, not all the tires in the bottom layer are multiple, only some of them are, because we wanted to keep the square feet same. This is how we perform the simulation analysis. As input, we put in the independent variables, and then as output, we got the dependent variables. So we took total number of iteration for all the 6 modules were 1,728. Each module was iterated with different parameters such as window to wall ratio, shading depth, U value, R value, and different values were used, and number of iterations can be seen here. This is how we generated the simulations. This is as you can see, the red denotes that the warmer condition, and the blue denotes the cooler conditions. As a container is made of steel, this was highly important for us to address. Here you can see the box plotting of the module 1. We only took one module, as the scope of this paper only covers one module. We iterated through that. The average UDI, you can see it gets cooler while UI goes lesser. They are proportionally inverse. And here we can see the MANOVA and ANOVA box plotting features. So here another thing, another aspect of it, that window to wall ratio on north, west, south, and east. With every condition, we can see that the more the EUI, the less the UDI. So whenever we get more UDI, that is more suggested, that is a better option. So we try to achieve all of these. These are the results that we finally achieved. Here, energy optimization, we took several results and plotted them, and then we got some benchmarks. So here, if you can concentrate on the first picture, you can see the when we took window to wall ratio 0.3, it is below 80. The useful daylight index is below 80, but when we used 0.6, it goes up. So that gave us a clear indication of how what the window to wall ratio on the north side could be. Again, if we look at the and if you remember, UDI we need higher, and EUI we need lower. So if you look at the EUI at the bottom right corner. Here, when we take the median 0.2, it is near about 90. The green, when we take 0.4, it is of a acceptable range. But then again, when we raise to 0.6, EUI again goes to goes below. Sorry. So our limitation of this study was that we could not iterate more numbers. With it is our learning from here that we need to set more benchmarks to have a better iterated result, optimized result. So speaking of limitations, I will these are limitations as well as learnings for us. The prototyping took about 60 hours to simulate, and this can be improved through machine learning. And also we can include augmented and virtual realities processes to involve the participants, involve the local communities to iterate how they want and to visualize how they want their houses to be built. Multi-objective optimization analysis can be implemented. Here we had two major concerns, major focuses, which was daylight optimization and energy optimization. So more parameters can be set, like square feet and interior design and roofing materials, and all these things can be incorporated for further and more richer research. Sensitivity analysis was needed to simplify design optimization process, and the comparison between all six module combination would have generated more optimization possibility. Why we kept it to one module here is because we are envisioning this as a chain of researches that will culminate together to produce better results. As this is the first time we are doing something like this in Bangladesh, this has not been done before. This type of container housing cluster system for affordable, which is affordable for lower income communities. So this we see as and in the future that it can be studied much more. Our future application is creating awareness amongst architects and policymakers about the growing need for coastal resilience. It is not only about storm. The housing, the disaster resilient housing and shelters are more of stilt construction, which works greatly with when battling floods. But for cyclone, we need stronger and sturdier materials, and so that the people are empowered themselves. So we see this as a future application. And by analyzing each module in the future, the combination and introdynamics can change the results and has the potential to be tweaked as per requirements. So because context is very important, we have we have talked about coastal region and specifically Chittagong, but even the other coastal regions in Bangladesh, these can be applied there, but they need to be tweaked based on context. And the number of shading and parameter was overlooked for iterations due to the control number. Shading devices can also be added and simulated to find out the optimum shading amount. And by establishing a novel framework with which further research can potential to become a key part in this field of study. So our outcome, the total outcome that we had from this establishing the research framework, which can allow us to explore further. So to conclude the whole session, I would like to welcome you all to watch this video.
Thank you very much.
This study started by addressing the climate issues, impact on informal settlements in the coastal areas, and their needs to bounce back from natural calamities. It ends by establishing a novel framework, which, with further research, has the potential to become a key part, and opens up another avenue for researchers to ponder about affordable, resilient, and sustainable housing in the coastal regions facing natural disasters and the following climate alteration and its impacts. Thank you so much.
Thank you very
And if
much.
you have any questions, I would like my co-authors to answer them, and or you can send us an email. This is a shared email. We are four architect friends who have started this journey together to research. We are young researchers, and please excuse if there was any fault in my presentation. I'm a bit nervous. This is the first time I'm presenting in such a big platform.